Hello and welcome to ITProTV. You're watching the CompTIA IT Fundamentals for exam FC0-U61. I'm your host, Ronnie Wong, and today we're going to dive into the realm of database concepts. And here to help us understand that, of course, is going to be Mr. Don Pezet himself. Don, welcome to the show. How are you doing?
Hey, thanks for having me back, Ronnie. And one of the purposes of the IT Fundamentals course is to expose the viewers to several different areas of IT, just ITProTV, but of IT. And let you see kind of the different types of work that happens in your average IT department. Well, one area that has grown exponentially over the last decade, or really the last 2 decades, is the area of database administration. Databases have become mission critical to many, many companies, have just become a key component of any kind of business logic or function, and are just really incredibly important. So sadly, it's kind of disturbing to see where databases are kind of mysterious to people, where a lot of people don't touch them, know that they're, know what they are, and understand what they do. So in the next couple of episodes, what we're going to do is we're going to focus on databases and show exactly what they are, how they work, how they do what they do, in the hopes that it piques your interest and encourages you to continue going on and learning more about database administration. But in this first episode, I wanted to keep it easy and start with database concepts. If you've never worked with a database before, if you don't exactly know what a database is, let's just start there and figure out what is a database, how does it work, how does it do what it does. And then in the next couple of episodes, we'll get a little more into working with them and seeing what they do. But for right now, I just want to set up what that base understanding is. So that's what we've got coming up right here in this episode.
Now, Don, I've talked to several people before, and they've told me they know exactly what a database is. And when they show me what one is, they just show me an Excel spreadsheet. Is that what we're talking about when we talk about what a database really is?
Sort of, yeah. I mean, it's a type of database. The example I use, and this is not so good for younger people, is like an encyclopedia, right? If you're a little older, like for me, we had a paper encyclopedia as a kid, a big set of volumes, A through Z, and when I wanted to figure something out, I could go here and I could pull it up and I could see it. That encyclopedia set was a database. It was a collection of data arranged in a way where I could find what I wanted. If I wanted to look up the Queen of England, I could go and grab the Q volume, flip to Queen, and probably find it. Or I could go and grab the E volume and find England, and it might tell me I'm in the wrong spot, and I need to go to the U volume for United Kingdom or something like that. But it would point me in the right direction. I would get the data that I wanted. I would get my answer. Today, we don't see databases as like a giant collection of books because books weren't very efficient. It took a while for me to go in there and find that stuff, right? To say, I'm going to go to that Q volume that then sent me to the U volume that then sent me to wherever it was. Like, it took a lot of time to find the information that I wanted. And the data got out of date pretty quick. Encyclopedias were expensive. I didn't buy one every single year. So you'd have a set. I remember the set I was using as a kid was like 20 years old. And as long as I was dealing with history, it was fine. But if I wanted current events, I was out of luck. Well, today we have things like Wikipedia, right? Wikipedia is a database. It's actually a massive one. Here, let me bring up. We're going to bring up Wikipedia here. So if I go to Wikipedia and I want to learn something like Queen of England, right? I'm just coming in here and I'm typing Queen of England, right? So I'm going to type that one in and I'm going to search for it. Now, I didn't have to go and find a volume, but somebody did in the background. The computer system did it. It has this collection of data, and it went in and it found Queen of England, and it said, hey, guess what, Don? There's been more than one queen. So this is not necessarily the best search I could have done. And it's doing disambiguation and telling me, actually, I'm probably meant to look for some of these other things. And sure enough, it's saying, hey, you could go and look up United Kingdom, or you could go and look up specific queens if I wanted to find them and look that up and get at it, right? So maybe I wanted just the general role, or maybe I wanted somebody specific, like Elizabeth II. And I can click on that and I start to get that information, and there it is, right? This data is coming from a database, and the database is massive, packed full of a ton of information. I need to be able to get at that information, and that's what a database is all about. Now, Ronnie said, what about Excel, right? What about Microsoft Excel? If I fire up a spreadsheet and I put some data in there, isn't that a database? Yes, it is, right? The difference is how much data you can fit in it. An Excel spreadsheet, that's designed really just to support one person, right? One person at a time gets in there and works with it, gets their data out. It doesn't scale all that well, right? But a database can. How many people are on Wikipedia right now? I don't know, but I'm sure it's in the tens of thousands simultaneously in there right now. Millions of people use it every single year, and it does just fine. When I did that search, was there a big delay? Did I have to wait while it processed and calculated? No, it already knew to churn out that information. Now, I don't know how many people are searching for the Queen of England right now. There's probably not that many, but it didn't even bat an eye. It just immediately churned up those results and got them out to me. So that's the big thing that databases do. Now, I used Wikipedia as an example, which is not really, I don't know, the most like business useful type thing, Wikipedia, non-verifiable information. But there are a lot of databases out there that have critical data in there that's really useful for making business decisions or powering businesses. A better example might be Amazon.com, right? If I go to Amazon.com, I'm going to go to their website, right? And first off, it's displaying a bunch of products. Looks like a bunch of junk that I could buy. So here's junk I could buy, right? But I want to buy something specific. I want to buy the X-Files on DVD. So I can come in here and type X-Files DVD, right? And so it's going to search, and it searches their database. They have a database of all of the products they sell with the prices that are available and whether they have prime shipping and all that's in a database. And it gets searched, and it shows me the products, and I come in, I can find the complete series and movie collection. This is like everything that I could possibly want, all right here in this product, right? And it finds it quickly, it displays it. Now I can buy it. This is a business being driven by this database. There's plenty of high level examples like that. The U.S. Census, where they collect information about all of the citizens here in the United States, so they can figure out how to portion out tax money and other things. Who knows what they do with all the data these days? But they collect all that information. That's stored in a database so that we can then act on it, right? Databases are key pieces to making good business decisions. If you make a decision, the quality of your decision depends on the information you have. If you don't have a lot of information, the odds are you're going to make a bad choice. But if you have a ton of information, the odds are you're going to make a good choice. Databases give us that information. Well, even a database is only as good as the data you put into it. So assuming we put complete information in there, it works really well. So for example, imagine Amazon, they have all of their products listed in this database. But let's say somebody gets a jar of peanut butter, and they forget to put it in the database. They stick it on the shelf at Amazon, but they never put it in the database. Well, nobody's going to find it. They'll come in and they'll search for peanut butter or whatever. See, this is where I go off script and then I do a search and something bad comes up. But hopefully peanut butter is a pretty safe thing to search for. So they search for it, and I find all these other ones that are in the database, but this one jar they forgot to put in there. Well, it's just going to sit on the shelf, and it's not going to get sold, and eventually it's going to go bad, and it's going to get thrown out, right? A database is not perfect. It's not a wizard. It's as good as the data we put into it. And once the data is there, we can then make good decisions. That's really what databases are all about, and that's really what's powering things, is that we're creating records, information, collections of data, and we're storing it right here in that database. And the database might be small. It might fit on one computer, right? Like an Excel spreadsheet does. Or the database might be massive. Wikipedia has a massive database that is spread across hundreds of servers to be able to handle that. Large amounts of storage and data, because they have not just articles, but pictures and things. I mean, it takes a lot of storage to store a bright pink like that. So it takes a lot of effort for that. And that is part of what databases do. So it's really an impressive technology that's incredibly powerful.
Now, Don, the idea of you showing us all this information helps us out because we know that we can go and use these things on a daily basis. But that means that someone behind the scene has to get the database information together, right?
Absolutely. Yep. So there's data input. There's a couple of different operations we do with the database. We've got to put data into it. That's input. Then we get data out of it. That's output, right? So you can't get data out unless the data has already been put in the first place. And these two things are happening constantly, over and over and over again. Well, I guess there are some examples where it only happens once. Right? For example, that census data I mentioned, that in the year 2010, they did a census. They collected all the data on the citizenry. They put it in a database. Is that going to change in 2011, 2012? Here we are in 2018. Is the data from 2010 going to change? Not likely. So the input happened once. They input all that data from 2010, but on the output side, I might ask questions about 2010 over and over again for the next 200 years. We might be checking like, what was the gender division ratio or the racial ratios and things like that to find out which minorities are growing into majorities, which majorities are shrinking into minorities, and so on, and figuring out where different people are living, different economic backgrounds. Those are questions we'll ask for hundreds of years, right? And so the output is happening way, way more. Amazon, same way. Amazon's only adding so many products to their database in a given day, but people are ordering millions of things on a regular basis. They generate an insane amount of revenue. So those are standard database operations. Now, when we're working with the database, we don't see a pretty web page. We don't see a shopping cart. We see the raw data, which is very different. So let me show you an example of that. I've got a database pulled up. So this database server here that I'm using is called Microsoft SQL Server. There's a number of database products that are out there. Oracle has a database product that is very popular. There is MySQL, MariaDB, PostgreSQL. There's a number of different database servers that are out there. But almost all of them function the same way and use the same language, a language called SQL. And the SQL, or the standard query language, is a language we use to talk to the database servers to get information out. And we're going to see SQL in another episode. But when I go in here, the database structures are pretty much going to be the same across all the various products that I just described. Is that you have a database. Here I have a database called AdventureWorks 2016. All right. And inside of that database, I have tables. And what tables are collections of data. I have data that gets input, that gets put into this system. And as I look in here, I can find things like employee records and so on. So this company, I have a fictitious company here that's called AdventureWorks, and they have employees. And so their data is being stored right here in this human resources.employee table. And when a new employee gets hired, they need to get added to this table. Now, if you watched our episode on business and productivity applications, you saw Microsoft Excel. And in Excel, you had a table, right? Basically a grid of data. Well, in a database, you have the same thing. If I were to edit this table, when I pull up the table itself, here, I'll just edit the top 200 rows. When I pull it up, I'm going to see a similar grid to what we would see in Excel, all right? And as I look at that grid, I can see that I've got column names, business entity ID, login ID, organization name, job title, and so on. And the data is all just stored right here in cells. And so I could come in and I could edit some of this. I could edit it directly, right? So maybe I've got an employee here who has a title. This is the Vice President of Engineering. And they get a promotion. And I say, all right, well, they're not the Vice President of Engineering anymore. Or maybe they're the Senior Vice President of Engineering. So we can come in and we can edit that record and change the value. If I can type it, that's the hardest part. And now they're the Senior Vice President of Engineering. And if I were to query against this database, I'm now going to see that new title attached to that person. We can jump in, modify that stuff, and get it put in. Somebody has to add these records. And if you're just adding them onesie-twosie, like you would in Excel, you just type them in. It's all manual data entry, right? But databases are designed to handle millions, billions of rows, right? Huge amounts of data. And when you do that, you're not normally directly entering data in. It's normally programmatic. We have software that's dumping the data in for us. And that might be getting data entered in. It might be exporting the data, backing it up, right? There's different things that you can do all programmatically. So when we look at the information here, it's usually information overload. It's way more data than what we want. So when we're working with a database, what we'll normally do is write what are called queries. And a query is a question where we ask the database for something very specific. And we say, look, I know you got a ton of data. That's great. But all I really need is this one little thing. Can you please give it to me? And the server can then sift through all of this data and give us what we want, right? A lot of people refer to these as reports. Think about it. A report is really just a summary of some other kind of information that's too complex to look at, right? If I want to know what's on television right now, if I were to look at the programming schedules for every TV station out there, it's a nightmare. But if I just pull up the little TV guide and I can see what's on right now, this 1 hour, what's on the various channels that I have. That's a report. It's giving me a subset of data that is far easier to handle. I don't need the last 10 years worth of TV schedule. I just need this hour. What's on right now? And that's how these databases work. So for example, let me show you, I have a query that I wrote before the show, which I thought I had sitting around here, but maybe I don't. So let me just open up this query here. Here, employee hire dates. So I wrote a query before the show, and this is what a query looks like. And again, we're going to talk more about queries later on. But what I'm doing is I'm telling the database I want a few things. I don't want everything the database has. I want the first name, last name, job title, and hire date of my employees. Can you please just give me that? Give me that data, just their name, their title, and when they were hired. And if you can give me that information, it would really make my life easier. And when we run that query, you're sending that question to the server. And the server gets it and says, okay, I will give you what you're asking for. And as I look down here, I can see a nice little table with the first name, last name, job title, and hire date of every employee. And that really makes life easier. This report, this data that I'm exporting here, that's exactly what I wanted. I've got that information, and now I have it, right? And I can use it. And I might use this versus using the actual data in the database because this is represented the way I want. And the cool part about these questions is you can rephrase them different ways, right? When I look at this, what is it sorted by? It's actually not sorted by anything, is it? It looked kind of random. I figured it would sort on one column. Usually databases sort on one column or another. This one doesn't appear to have sorted on anything, which means it's sorted based on the date they were entered. So Ken Sanchez was the first person to be entered in the database, which makes sense because he's the chief executive officer. He was probably employee number 1. And then we've got the senior vice president of engineering, Terry Duffy. And then it goes down the line. So this is just the order of entry. Well, maybe that's not what I want. Maybe I want it based on their hire date. I want to know, which, actually, if I look at the hire date, Ken Sanchez was added after some of the other, I don't know what this is sorted by, right? So we can tell the database when we ask it to give us data, we can say, you know what, could you please sort this? Maybe sort it by last name, right? Or sort it by hire date. I want to know who actually was hired first. So I can just come in and I can say, I can try and type order by, and then what it is I do want to order them by. So maybe it is hire date, and I can punch that in. And now when I rerun this query, I should see everything sorted by that hire date. So I'm going to rerun the query. And Ken Sanchez is not first in the list anymore because he wasn't the first person hired. In fact, way back in 2006, it looks like we hired a production technician named Guy Gilbert. Manly name. So Guy Gilbert came on in 2006. He was the first employee. Kevin Brown came next with marketing because we have a product. We need to market it, right? So I guess that makes sense. And then they go through and they start to add more people. I could easily change that and say, I didn't actually want hire date. Instead, let's sort this one by last name. And when we do last name, rerun that query. And this time it's going to be reorganized and changed the way we want it. And Syed Abbas is now the first one. Even though he was hired in 2013, his last name starts with A, B, and so he comes first, right? So this is the power of a database. You have a massive collection of data, and you can sit there and ask it questions, all sorts of different questions, and you can generate all sorts of information based on the results of those questions, and then you can make intelligent business decisions based on all of those.
Now, Don, everything that you're showing here is neat and is amazing, but I still don't see why it's really that different from an Excel spreadsheet. So why not continue to use something just like an Excel spreadsheet?
All right, so we could, right? We could use Excel, right? It has a table. You can put your information in there. The thing about Excel is it just doesn't scale very well. Excel has a maximum of 65,000 columns, which admittedly is a lot of columns. You're rarely going to need that many. But it also has a limit of about 1 million rows. When we're dealing with databases like this, we could have billions or even trillions of rows. You could have huge amounts of data, and databases are designed to handle it. But the key difference, the main difference, is how many people can be in the system at once. Excel is expecting one person to access a spreadsheet at a time. And the bigger that spreadsheet is, the longer any kind of reporting is going to take to generate on it because it's having to generate those results in real time. Right? Databases, on the other hand, are designed for tons of people to be in them at one time. And it doesn't matter how big your data gets, that all these people getting in there will still be able to get results really, really quickly. And the reason is that the database is expecting me to run queries more than once. Excel isn't. Excel expects you to run a report or whatever one time. And so it's doing the work over and over again every time you run that report. In a database, though, you have what's called a query execution plan. And let me just bring this up. And this is something hopefully most of you never have to deal with. But when I ran this query, a lot of work actually had to happen in the background. We didn't see that work. And if I take a look at this, it can come in and show me what that work was. So let me bring that up here so we can see it. And if I can stretch this window just a little bit, whatever, I can't get my mouse on it. But basically you see this little chart right here. And this is all that happened in the background. It had to do some clustered index scans. It had to take the results from those scans, do a join, and loop them together. And once it had them all joined, then it had to sort them, because I asked it to sort, before it gave me the results. All of this work had to be done. Well, the database server figured out the best way to do it to get the results as quickly as possible. And you saw it ran really quick. In fact, it tells me on here somewhere, down here at the bottom, my head's on top of it. But it tells me that query ran in less than 1 second, right? And that's actually tenths of a second. And then we've got 290 rows. I got 290 results back in less than a second. It was able to process that really, really quickly. This is not just being run for me, but now the server saves that data. And it says if somebody else runs this same report, I already know how to do it. I might even still have the results in RAM, and I can just give them the results without even running the query. And that makes this far more efficient. If Amazon was having to reparse their entire product library every time somebody ran a search, it would take forever. Their cost would be through the roof for the hardware to support that. But because the searches have already been done and they're already cached, you get the results way faster. So performance and scalability, that's what databases bring. You can do a lot with Excel, right? I could recreate this exact stuff right here in Excel, and it would work fine if it was just me. But when you talk about scalability, supporting an entire company, supporting your customers, those flat files, those things like CSVs and Excel spreadsheets and other workbooks, they're not designed for that. They don't scale like that. Even more advanced applications like Microsoft Project and QuickBooks, where those are effectively databases, they're really only designed for a handful of people to be in them, not tens of thousands of people. That's what databases do, and that's what sets them apart.
Yeah, Don, I think another distinguishing feature of a database that helps us compare to an Excel file is that we can query from, multiple tables at one time as well. So the ability to not just query one Excel spreadsheet and then look for another one and figure it out, it allows us to connect those two together and be able to run that too. Now, Don, even though we're talking about this, and it did help us to understand that a little bit more, are there different types of databases that are out there, not just something like Microsoft SQL here?
There are, and databases kind of fall into three different categories. There's structured databases, semi-structured databases, and unstructured databases. Whatever. What I'm showing you here is what's called a structured database, right? It's a lot of people refer to it as a relational database. The data is all arranged in a certain way. I have a lot of tables over here. All of these tables would be like separate Excel worksheets, right? Except the difference is that each table relates to another table somehow. And let me show you a graphic I whipped up before the show to give you an example of that. So here I have a table for my orders. I'm a company, I sell something, people place an order with me. So I have an order. And an order contains an order ID, and then it's going to contain who placed the order, right? So maybe there's a contact information, the product that was being purchased, a promo, if they had a discount code, that kind of stuff. That's all being tracked based on the order. Well, I also have customers. The customers, I might call them contacts, but they have first name, last name, phone, email. I have my products that have names, descriptions, they have a price or a cost. I have my promo codes. If I have discount coupons, what's the amount of the discount, right? These are all things that I have, but they're all related to each other. When I place an order is being placed by a contact. Somebody's buying something, and they're buying a product. That's the something. And they might be using a promo code. They might be getting a discount. All of this is related together. In a structured database, we have a very well enforced structure that defines what data goes in the table, and then we have relationships that define how it's tied together. Right? You can have a semi-structured database where there is a structure, but it's not really enforced. And when I talk about enforced, databases have what's called a schema, which is like a set of rules. You have to follow these rules. For example, I can't have an order unless it has a contact ID. I might have a restraint that says you've got to have that. But I don't have to have those kind of rules in place. I can make it semi-structured where maybe some records have values, some records don't. Columns might be considered optional. I might even have more than one copy of the database where certain columns don't even exist, right? And there might be data that doesn't even have a relationship with other data that I just need on certain occasions. There are fully unstructured databases where there is no structure, that each entity, each row just identifies some kind of concept. Those are called schemaless databases, and they have no rules. And that sounds really crazy. Like, why would I want a database without any rules? Those type of databases focus on speed, operating very, very fast. The whole database is usually designed to answer one question and one question only. Remember that query I wrote? That's a question, right? And if I have a very particular report, I can have an unstructured database that was designed just to feed that one report. Now, if I change my mind later and say, I want to ask it a different question, too bad. It doesn't work, right? The database is built to support that one question. In a relational database, you can ask it whatever question you want. The data relationships are all mapped, and you can ask it all sorts of different questions and can generate those results and give you what you need. So really, really flexible there. Now, in a relational database, which is the most common, that's when we talk about Microsoft SQL and Oracle and MariaDB, PostgreSQL, those are all relational databases, right? They're not so much designed for speed as they are for flexibility and power. They give you a lot of power to ask all the questions that you want. When you ask them questions, you're basically coming in and getting data out of a table like this. And you have a column like contact ID, and then in that table you have rows, and there'll be a value in that column for what the contact ID is for that particular order, and you get that information back. There are databases that are called NoSQL databases, or not only SQL. And what those do is make it where each row isn't necessarily aligned with a particular value. And with these, you'll usually have what's called a key/value database, where it actually identifies what the column name is in the row instead. So instead of having well-defined columns like this, I would just have a row that said order ID 5, first name Don, last name Pezet. And it's just all right there in that one entry. I've got the key and the value stored in the same entry. I'm not relying, I don't care what the column name is called, because everything I need is right there in the data that's being stored with it. Those are popular with big data, with massive, massive amounts of data, but they're usually tuned to answer one question. Any other type of question you ask would be incredibly inefficient, and you can have queries that take days to run. I can ask it the question, and 3 days go by before I finally get the information back. And it might sound like an exaggeration, but I've worked in that environment where I've had queries that literally took 72 hours to execute, and you got what you wanted. But usually there's some better way to rearrange that database to get the information you want. So those are examples. There is one other thing which is called a document database. And a document database is where instead of storing values like what we saw back here, instead of storing like names and text like this, a document database can store practically anything. It can store images in there, binary data. It can store archives, encrypted information. And now when I ask it questions, it's not able to do sorts and things of that nature, but it's able to present the data back to me. A great example of that would be like Google Maps. If you go to Google Maps and you do a search for your city, what you're actually doing is running a couple of searches. One search to actually figure out what your city is. So I'm in Gainesville, Florida, so I'm going to pull that up. But then it has to display the map. And they have a database where each map grid is stored in a different cell of this database. And it's able to query it and return the grids. That you really see that when you switch to satellite view. If I can remember how to get into satellite view. Somewhere in
Lower
here.
left-hand corner?
Lower left. Oh, yeah, where it says satellite. Thank you, Ronnie. So it's having to load pictures of each grid. And you've probably seen this before where when you start zooming in on it, where certain squares will light up and go detailed faster than others. And that's because they're getting returned a little more quickly. And as we continue to zoom in, which on the east side of town now instead of like where we are, we can probably find the ITProTV studios. But each one of these is basically loading a separate picture and stitching them together, and they're coming out of a database. It was there for just the briefest of moment. You might have noticed the blurry line that went halfway down the screen where one grid was already loaded and the other was still loading. It's pulling those out of a document database to be able to input this. So databases don't necessarily just store text. Sometimes they store pictures, binary data, other things like that. And there we go. That's going to pull up ITProTV Studios where we are right now. And so they've got this picture of our building, and you can see it, which no cars are here. They must have done this on a weekend or something. But you can grab that picture, you can see it, and now you basically pulled this from a database, but you never actually realized you were interacting with that database.
All right, Don, well, thank you for helping us to understand more about what a database actually is and, of course, what it can do for us, and even some of the different types of databases that are out there that we might encounter as we enter into the IT field as well. All right, Don, so here's your chance. Last words on database introduction on the concepts here.
All right, you use databases every single day, whether you know it or not. If you're watching this video, the way you got here was some database was queried to present this video to you so you could watch it. So they are involved in everything that you do. The question is whether or not you find it really exciting.
Right.
If you find it exciting, there's a whole world in here of how you get the data stored and optimized and queried. And so in the next 2 episodes, we're going to take a look at a little more of that, how the databases function, and we talk to them and so on. But if you are interested, we have a whole series of courses in the ITProTV library that really go in depth on working with databases. It's powerful stuff. It's fun. It's neat. And it's actually pretty rewarding because you generate this data that companies then use to be successful. So it's a really cool world. Definitely something you'll want to check out.
All right, thank you again, Don, for helping us with those final pieces of advice and finding out if that's exciting. But that's enough for us. Signing off for ITProTV, I'm your host, Ronnie Wong.
And I'm Don Pezet.
Stay tuned right here for more of the CompTIA IT Fundamentals Show.
Thank you for watching ITProTV.